Hello, good day everyone. I'm Casey, Crystal Cassandra Lim, and now that you have learned what EMV is or expected monetary value, as well as how it was computed, let's now take a look at some examples. So first we have here for project management. A construction project may have a 60% chance of being completed on time, resulting in a 100,000 profit and a 40,000 chance of delay, leading to 50,000 loss. The EMV would be, so what we did here is we multiplied the percentage of the probability to the 100,000 profit added by the product of um, the 40% chance of delays, leading to a 50,000 loss, which we have an answer of 40,000. Another is for the risk analysis. A company is considering launching a new product. There's a 20% chance that the product will be a huge success, a 50 chance it will be moderately successful, and a 30 chance it will be a failure. By calculating the EMV of each scenario, the company can assess the overall financial risk of launching the product. So, another we have, what we will do here in this part, we just multiply, we will assign, we have to assign profit and the resulting profit and the resulting loss. So for example, if there's a 20% chance of a product with a huge success with a profit of 10,000, what we will do is we just multiply it like what we did earlier in the product management example. Okay. And then add the product of the three three probabilities, and we will have an answer for our EMV. So for investment decision, so an investor is considering investing in a particular stock. There is a 70% chance the stock will increase in value by 5,000 and a 30% chance it will decrease by 2,000. The EMV would be, again, what we did here is just multiply the probability to the value, which is 70% multiplied by 5,000 added by the 30% chance, and the loss, and the loss, which is 2,000. So we have to always remember na if loss here, it should be negative, when wherein and profit po is positive po here. Okay, which is the result is 2,900. Next, we have here the examples of EMV of alternatives. So, an example is a business owner is deciding between two investment opportunities for the next quarter. Alternative A involves investing in a marketing campaign for an existing product. Based on past data, we have here 60% chance that the campaign will increase sales and result in 80,000 profit. Another is there is a 40% chance the campaign will fail to boost sales, leading to a 30,000 loss. Alternative B involves launching a new product. Market research suggests that there is a 50% chance it will be well received, earning 19,000 profit, while there is also a 50% chance it will flop, causing a 50,000 loss. First, solve for the alternative A, which would be seen in the screen. We have EMVA 60% multiplied to 80,000 plus 40% times negative 30,000, which is equivalent to 48,000, and minus 12,000, which we have a result of 36,000. Alternative B, we have here the 50% chance multiplied to 90,000 profit plus 50% times negative 50,000. So, 45,000 ang resultant first. Minus hiya, since negative man ang 50 and 50,000, so naging 25,000 hiya, equivalent to 20,000. So, based on the EMV, we'll have our decision, which is to choose the alternative A because it has a higher expected monetary value. Next, we have here the consideration and limitations of EMV. In terms of risk assessment, EMV provide a way to quantify the potential impact of different risks by multiplying the probability of each risk by its potential monetary impact. This help in identifying the risks that are most likely to affect the project bottom line, allowing for better resource allocation and mitigation strategies. So, EMV helps you prioritize risk by showing which risk could cost you the most based on how likely they are to happen. So, for example, we have risk A, 20% chance of losing 100,000, while risk B, 80% chance of losing 10,000. What we noticed here is the probability of risk A is less than the probability of risk B, which is 80% chance. Now, the result or the EMV for 20% times 100,000 would be negative 20,000, while 80% times negative 10 would be 8,000. Although risk B is more likely, risk A has a higher EMV loss. So you should focus more on mitigating risk A. It is also useful in decision making. By summing up the EMV of all possible outcomes, decision makers can make a more informed choice about the best course of action, as the EMV represents the expected financial outcome of each option. So, when choosing between options, EMV helps you choose the one with the best expected outcome, not just the safest or most profitable on the surface. So, for example, again, option 1, we have 50% chance of earning 100,000 and 50% chance of earning 0. So, 100,000 or nothing, 50-50 chances. In option B, we have guaranteed 40,000. Okay, so the EMV for the first one is of course 50,000, since 0.5 times 100,000 plus 0.5 times 0 would be 50,000. But option 1 has a higher EMV, so it's better choice based on math. But risk-tolerant people might go for it, while risk-averse people might prefer option 2 because it's a guaranteed 40,000. In project management, next slide, EMV is particularly useful in project management to assess the financial impact of potential risk, helping in budgeting, resource allocation, and contingency planning. So, EMV helps project managers budget better, prepare for potential losses, and set aside contingency funds. So, an example for this is that 10% chance of delay costing 200,000. 30,000 chance of additional supplier cost 50,000. So, to calculate it, the delay costing would be negative 20,000, while the supplier EMV would be 0.3 multiplied by 50,000, which would result to negative 15,000. So, if you add both, syempre, you will have a result of 35,000, which should be reserved as contingency fund in your budget. But EMV has limitations. We have first here uncertainty of probabilities. EMV assumes that the probabilities of these potential outcomes are known and constant, but in reality, these probabilities are often uncertain and can change over time. Probabilities may just be best guesses. not real data. If your guess is wrong, the EMV result is wrong too. For example, if you assume a 50% chance of risk occurring but the real chance is only 10%, your decision could be overly cautious. So I remember this from our risk management subject, wherein we assigned probabilities to risk, which we ranked them, which we multiplied them to the impact of the risk, and then we ranked the results, and which had highest value, we then chose it as the risk champion. So we just assumed that this we had our interview with the project manager, and we asked them if how often does this machine break down, and then the probability of this machine to have a downtime would be this, and then we calculated it. So it's just best guesses. So one of the limitations is uncertainty of probabilities. Next, we have lack of risk tolerance consideration. EMV doesn't take into account the individual's risk, which can influence decision making. Some individuals may be more willing to take risks than others, even if the EMV suggests otherwise. So EMV doesn't consider how comfortable a person is with risk. For example, even if EMV shows 50,000 as the better expected return, some people might still choose to the guaranteed 40,000 because they don't want to risk getting nothing. Another is subjective value. So, for subjective value, the monetary values assigned to outcome may not always reflect the true value that individuals place on those outcomes. A subjective factor and non-monetary values can also influence decision. So, not all outcomes have purely financial value. Example is, losing 10,000 might not hurt a big company, but could be a huge issue for a small startup. EMV treats them the same otherwise. So another we have for number 4, bias and data accuracy. EMV can be subject to bias due to expert judgment in certain cases, and inaccurate data can lead to flawed calculations, making the result unreliable. EMV calculates depend on accurate data and honest assessment. So for example is, if an expert wrongly estimates the risk of machine breakdown as 5% when it's really 25%, you'll be unprepared, 'di ba? So in conclusion, EMV is a valuable tool in economics for making decisions under uncertainty, assessing risk and evaluating the financial impact of various scenarios. By considering both probabilities and financial impacts, EMV helps decision makers make more informed choices and achieve better outcomes. So EMV is a smart way to make decisions involving uncertainty, especially in businesses, economics, or project planning. It helps compare risk and reward based on math, not just guesswork. But it's not perfect. It ignores emotions, human behaviors, and the fact that we can't always predict the future exactly. That would be all. Thank you so much.